In this video, we're going to talk about how to solve an equivalent system of equations. There are a couple different signs for equivalent. For today, there's one important question. If we have a system of equations that's not a good candidate for graphing, the substitution method, or the elimination method, what else can we do? What other methods can we use? Suppose we have a system of linear equations, and other methods, like the substitution or elimination method, aren't good candidates. So for example, let's take this system, 3x minus 8y equals negative 17, and negative 6x plus 6y equals negative 6. You'll notice that we don't have any variable that's already alone with a coefficient of 1. So that means that the substitution method isn't a good option for this system. The elimination method also isn't a good choice because we don't have any variables with the same coefficient or opposite coefficient in the two equations. We have a 3x and a negative 6x. We have a negative 8y and a 6y. So elimination isn't a good choice either. So what does that leave us with? So what we can do is tweak or manipulate these equations a little bit so that they'll still have the same meaning, they'll still have the same solution, but they'll look a little bit different, and that'll make them easier to work with. So we want to tweak these equations to make them a good candidate for the elimination method. That means we want the x or the y terms to have the same or opposite coefficients. So for elimination, remember, we can focus on the x terms or the y terms. So here the coefficients on the x terms are 3 and negative 6. And on the y terms, the coefficients are negative 8 and 6. So let's think about which pair might be easier to manipulate and make it work for the elimination method, 3 and 6 or 8 and 6. 3 and 6 is the better option because 3 times 2 will become 6. 8 and 6, we'd have to work a little harder to find a common multiple. It's not impossible, but we'd have to work a little harder. So let's focus on the x terms. So we want the coefficients on both x terms to be the same or opposites. So that top equation, the first equation in the system, we're going to multiply the left and right side of the equation by 2. By doing that, we haven't really changed the system at all. That new equation still represents the same information as the original equation. We've just multiplied both sides by 2, but they're still equal. So let's do that. We'll multiply both sides by 2, and we'll get this new equation. 2 times 3x is 6x, 2 times negative 8y is negative 16y, and 2 times negative 17 is negative 34. So we have this new equation, 6x minus 16y equals negative 34, and that's equivalent to the equation that we started with. So we started with these two equations in our system. Now this first one we've just manipulated by multiplying it by 2 on both sides and gotten this new equation that's highlighted here in yellow. So now we can do away with this first equation. We don't need it anymore. It's redundant. We've got two new equations, one from the original pair and one new one. And now we have a good candidate for the elimination method because the x coefficients are negative 6 and 6. And because these two coefficients, negative 6 and 6, are opposites, one positive and one negative, we can add these equations together to eliminate the x term. So when we add those two equations, we'll get negative 6x plus 6x equals 0, so that disappears. 6y plus negative 16y is negative 10y, and negative 6 plus negative 34 is negative 40. Now we found y equals 4, but we're not done yet. We still need to find x. Remember that the solution of a system of equations is a point, x comma y. So we have y, and now we need to find x. So we found y equals 4, so now we can substitute any place we see y in any of these previous equations with the number 4. So let's use this second equation. Negative 6x plus 6y, and we'll replace that y with a 4, so 6 times 4 equals negative 6. And then we can just solve that one variable equation and find x. In this next system, once again, we want to tweak the equations a little bit to make the numbers, either the coefficients of x or the coefficients of y, friendlier for the elimination method. In the first example, we saw that one equation we could just multiply both sides by 2, and the second equation we could leave as is. But that's not going to work here. We're going to have to tweak both equations. So in this example, notice that we have 8x and 6x, and then we have 7y and 6y. So which of those pairs do you think would be easier to make it work for the elimination method? Before we had 3 and 6, and that was easy. 3 times 2 becomes 6, and we leave the 6 as it is. But 8 and 6 and 7 and 6 are not so simple. We can still make it work though. So let's think about the multiples of 8. 8 times 1, 8 times 2, 8 times 3. When is the first time that a multiple of 8 is the same as a multiple of 6? What's their least common multiple? 8 times 2 is 16. That's not a multiple of 6. 8 times 3 is 24. That is a multiple of 6. 6 times 4 is 24. So 8 times 3 and 6 times 4 will give us the same coefficient, 24. If we were to try to do this with the y coefficients, 7 and 6, we can think about the multiples of 7. We've got 7, 14, 21, 28, 35, 42. Finally, we hit on a multiple of 7 that's also a multiple of 6. So it works, but it's just not as nice as working with the x coefficients. So we'll focus on the x coefficients, 8 and 6, and remember we want both of them to become 24 so that we can eliminate them. So this top equation that starts with 8x will multiply both sides by 3. And that'll create a new equivalent expression. So now we don't need this first equation anymore. It's redundant. And now looking at the second equation that starts with 6x, we're going to multiply both sides by 4. And again, this will give us a new equivalent equation starting with 24x. And we can get rid of that second equation because it's redundant now. So both of our original equations from the beginning of this problem are now redundant. We don't need them. But the two equations we're left with represent the same system. They're equivalent. And, more importantly, they both have a term of 24x, which makes them a great candidate for the elimination method. So now we've got these two new equations. Both of them have a term of 24x. And you notice these are not opposites. They're both positive. So if we add these equations, we're going to get 48x, when what we really want is for the x term to disappear. So what we need to do is subtract one equation from the other. And that means that each term is going to be subtracted. So 24x minus 24x is 0. Negative 21y minus negative 24y is 3y. And negative 45 minus negative 72 is 27. Be careful with those double negatives, and remember that subtracting a negative is the same thing as adding. So now we've found that y equals 9. So we can go back to any previous equation in this system and replace y with 9. So let's use this equation 24x minus 21y and replace that y with a 9 equals negative 45. And then we can solve this one variable equation. Once we finish that, we found that x equals 6. Now we're finished. We found x and y. So the point where the lines represented by these equations intersect is the point 6, 9. So now to wrap up, let's think about that question from the beginning of the video again. If we have a system of linear equations, and it's not a good candidate for graphing, or the substitution method, or the elimination method, what can we do? Well, we have to tweak the system a little bit to make it a good candidate for elimination. And we do that by choosing either the x coefficients or the y coefficients and multiplying the equations to make those coefficients the same number or opposite numbers. So if we have 3 and 6, we can multiply 3 times 2 and we'll get coefficients of 6 that can be eliminated. Sometimes, like in the first example, you'll just tweak one of the equations and that'll be enough. But other times you'll have to tweak both equations. And a good way to do this is to think about the least common multiple of the coefficients that you're working with. Once you've got those coefficients to be the same or opposite numbers, the problem works exactly the same as any other system that you solve using elimination. That's all for today. Thank you so much for watching and have a great day.